Hi, I'm John Nischel from Juniper's Cloud Ready Data Center team, and welcome to this webinar titled Clouds and Network. Now, that might be an interesting or odd title for some of you depending on your point of view, but consider that compute, storage, and applications are just points in space without the network. Now, admittedly, I'm a networking guy, but for me, that was when the concepts of cloud really came together. So in this webinar, I'll share some insight about cloud technologies used by service providers and hyperscalers, and how this evolving and interesting relationship has changed the landscape of the network operator market. While this is intended as a technology and market overview, I will review Juniper's approach to private, public, and hybrid clouds, and I'll introduce some of Juniper's cloud and data center networking products to add context to examples and use cases. For the agenda, we will first look at network operator market trends and the unique relationship between communication service providers, or CSPs, and the hyperscalers. We'll then look at the evolution to hybrid clouds, and I'll talk specifically about Telco Cloud technologies, including a drill down into the challenges of 5G microservices. Now, if you're like me and you see a TAM slide, you kind of gloss over. I mean, the numbers are incomprehensibly large. So I want to focus more on market dynamics. If you've been in the industry for a while, you likely equate the term network operator to traditional telecom operators or service providers, or now what we call CSPs. Now, these are companies like Verizon, Deutsche Telekom, or NTT. But today's network operator market has evolved to include carrier-neutral operators, or CNOs. These are data center infrastructure players like Digital Realty and Equinix, or tower companies like Cellnex and American Tower, who make their money leasing managed facilities and infrastructure to other operators and enterprises. It's the smallest of the segments, but it has the highest growth rate at 12%. At the other end of the spectrum are the hyperscaler operators like AWS, Microsoft Azure, and Google Cloud. These are massive companies with forecasted revenues of $3.67 trillion with a T by 2026. Now, overall, it's a healthy market, but the growth of the telecom operators has stagnated at 1.3%, while the others are experiencing double-digit growth. So what's changed and why the disparity? Now, for years, these companies worked side by side as partners, staying in their own swim lanes, offering complementary or supplementary services to each other. The telecoms delivered networking and connectivity, hyperscalers delivered content and cloud and infrastructure, and the CNOs delivered managed real estate and co-location facilities. But over time, these operators began to cross into each other's swim lanes, using cloud technologies to introduce competitive services into their partner's backyard. So for example, CSPs delivering cloud services to enterprise verticals, which competes with the hyperscalers, hyperscalers offering private 5G services, which competes with the CSPs, and the CNOs offering RAN services, which could be for or against other operators depending on their own strategic approach. And these operators are still part of the same ecosystem, but now their swim lanes are more like suggestions. So again, we have to ask why. Why the disruption and what's at stake? Well, the answer is opportunity. And growth has historically been a strong measure of a company's health, but with the potential for economic challenges ahead, profitability is the new growth. Cloud as a development and service delivery platform can lower costs to increase profits, and shareholders like that model. So each of these segments have an equal opportunity to compete for any of these markets, but, and there's always a but, the telecoms began their cloud journey a little bit late, giving the others a significant advantage. So if you're a telecom operator, what do? Well, you look for opportunities to gain some advantage and even things out. In this case, the telecoms turn to the hyperscalers. And the hyperscalers? They're here to help, or are they? I mean, you call it frenemies, friends with benefits, co-opetition. On the surface, it's a totally logical partnership for the telecoms. The hyperscalers developed the cloud and virtualization technologies we use today, so they're the masters of their craft. They are the Bruce Lee of cloud. But even the biggest cynics are going to agree that this relationship has challenges. Things started off pretty normal with CSPs partnering with the hyperscalers to host their business and IT workloads, and the relationship evolved from there. But it was the decision by Dish to run their 5G services from the AWS cloud and the purchase of AT&T's cloud services by Microsoft that was a tipping point in the relationship. There was a real watershed moment when the telecom industry announced that hyperscalers would be an important part of their own growth strategy. So at the same time, things got a little more contentious as both hyperscalers and CSPs introduced competitive service offerings. CSPs looked to multi-cloud, but look, multi-cloud is really hard to do, even for the largest of the CSPs. Which brings us to 2023, and the hyperscalers are the big fish in the network operator market. Now, there's nothing nefarious that's going on here. This is just good business development and product management. They're identifying market opportunities and developing solutions to fill the void. So here we are. CSPs and hyperscalers are working together, but the CSPs are looking for a little more independence and control. But why? I mean, if it works some of the time, wouldn't the CSPs run everything in the public cloud? Well, it boils down to economics and the paradox of the cloud, which states you're crazy if you don't start in the cloud, but you're crazy if you stay on it. To give you an example, this green line represents a typical life cycle curve for a service or an application. In the early stages, cloud makes total sense because the value of having on-demand infrastructure, precise scale, expertise on demand, and time to market outweigh the premium of the public cloud. This is something we call here the flexibility tax, which is essentially lost profit. As the service matures and the growth curve flattens, the need for on-demand and elastic resources gets reduced, if not eliminated. So the premium cost of the cloud becomes a burden, consuming as much as 50 to 80% of profits. And somewhere along the growth curve, it becomes much more cost efficient to repatriate workloads. A new industry buzzword. It just means to pull them back from the public cloud and host them in private clouds to lower costs and increase profit. Now, for some, this may not be practical, but if networking cloud to your business, you can and you have to make this work. To do this, it requires that CSPs have their own private cloud platforms, which means that somewhere during this relationship with the hyperscalers, CSPs invest in their own cloud so that they can gain back some control and protect their share of the revenue. Now, this model for running workloads in both private cloud and public clouds is the definition of hybrid cloud, which in our view is the most strategic way for CSPs to evolve forward, participate in the cloud economy, grow revenues, and control their share of the profit pool. The hybrid cloud model is well suited for any of these telecom use cases like SPIT for business apps, Edge and Telco Clouds for telco workloads like 4G and 5G, and enterprise managed services for business and consumers. Hybrid cloud isn't just a solid cloud architecture, it's a smart business model that establishes an exit strategy when the partner cost exceeds value. So for the rest of this webinar, I'm going to drill down a little bit more into the hybrid cloud architectures, specifically around telco cloud services like 5G. Now, the path to Telco Cloud isn't without its challenges, but there are 3 pillars we've identified that are key to success. These clouds have to be automated, assured, and secured. Now, as we learned in our partnership and success with Deutsche Telekom and their next generation IMS cloud, it starts with automation. The automation architecture has to be defined as a first step with buy-in from all stakeholders so that every aspect of the cloud, from the underlay to the overlay to the VNFs and CNFs that run in the cloud, are automated. If it moves, it needs to be automated. Second, cloud technologies span physical and virtual boundaries, which makes service assurance super challenging. Now, CSPs need tools to catch and resolve issues before their customers experience issues that might result in churn or lost revenue. And that's not easy to do. And third, telco clouds have to be secured, with strong security strategies to secure east-west traffic across the VMs and containers that deliver telco services, and north-south traffic that crosses the physical and virtual boundaries. Let's first drill down into automation. I think it's pretty safe to say that most of us are guilty of viewing Telco Cloud as a set of technologies, and from that perspective, Telco Cloud looks really hard. At the physical level, you have compute and storage, you have networking, you have pluggable optics, and miles of cabling that need to be connected, integrated, operationalized for production network. The racks themselves are connected across spine, leaf, top of rack, and bottom of rack switches, usually from multiple vendors, which requires a team of skilled CLI jockeys to get them configured. Now, it's manually intensive, error-prone, and extremely time-consuming. Now, on the top of the physical underlay, you have the virtualized and containerized workloads, the VNFs, CNFs, and orchestration systems like OpenStack and Kubernetes, where networking isn't a part of the orchestration stack. So pods and workloads are born into the cloud with an open mic to talk to whoever they want. It's inherently insecure. Instead, Kubernetes uses the Container Network Interface, or the CNI, to add networking policy and security for these ephemeral workloads that can appear, grow, shrink, move, and disappear. So, okay, it does sound pretty complex, but by viewing cloud as a set of technologies, CSPs focused on virtualizing the service without changing their business models, and that's kind of like buying a vacuum and trying to use it like a broom. But when CSPs adopted Telco Cloud as an operational model, they reaped the benefits of cloud automation. So let's take a look at 2 of Juniper's products that help to automate the data center, starting with Apstra. Apstra is a day 0 through day 2 data center automation application that converts racks of data center switches into what Juniper calls the Cloud Metro, a network fabric that connects the RAN, edge clouds, telco clouds, and data centers into one unified cloud. And there's some great videos on our Apstra demo page to give you lots of details, but what I love about Apstra is that it's truly multi-vendor. You can deploy switches based on your criteria: cost, performance, density. Maybe it's a supply chain issue and you need to check out an alternative vendor. In all these cases, you use intent-based language to develop a profile, and Apstra renders the configuration. There's no need to write hundreds of lines of code or remember the CLI syntax for different operating systems. Apstra even checks the config for errors before you push to production. It's a game-changing technology. So while Apstra automates everything from the NIC card into the fabric, Juniper's cloud-native Contrail networking, or CN2 for short, is our software-defined networking for the virtualized and containerized workloads running on the network data center servers. CN2 runs as a Kubernetes native application, which means that as compute and storage are spun up, Kubernetes uses the CNI to request networking and security policies from CN2 for these new clusters and pods. So in other words, if we're adding a pod for the blue network, let's just make sure that only members of the same blue network can access the service. Let me take a minute to walk you through a simple example to demonstrate. As an SDN, CN2 has two components: a control plane that runs in its own cluster represented by the large CN2 icon on the left, and a forwarding plane called the vRouter that runs on every physical server connected to the fabric represented by the small CN2 icons on the right. The vRouter can run in the Linux kernel, the Data Plane Development Kit, or DPDK, or a SmartNIC, depending on your performance requirements. In this example, I have two physical servers named Host 1 and Host 2, each running a vRouter, and we're running a three-tier application with a web front end, an application, and a database backend. Kubernetes treats server nodes as just logical bank of compute, so as a result, we have the web pods running on host 1, the database pods running on host 2, and the app pods in the middle, running across both hosts. With network and security policy distributed from the CN2 controller, the vRouters handle all L2 and L3 traffic without ever leaving the server, while all non-local traffic is tunneled across the underlay without changing IP addresses or worrying about overlapping IP address ranges. In fact, CN2 and Apstra are now integrated to connect the underlay and overlay layers so that pods deployed in containers and pods deployed on SR-IOV hosts can be automatically detected and plumbed for networking without trouble tickets or manual intervention. You can learn more about this technology on our CN2 demo page, but to sum things up, this combination of underlay and overlay automation converts some very complex technologies into a completely automated cloud platform. Now, automation software isn't just practical, it's fundamental to realizing the full value of what cloud can deliver to your business. And in fairness, the path can be complex, but we know firsthand that Telco Cloud isn't only achievable, the results can be transformative. We helped one of our major Tier 1 operators to modernize their Telco Cloud deployment, starting with the foundation built around automation. The results have been amazing. Using DevOps and CI/CD pipelines, this customer automated 97% of their test cases, which dramatically reduced the time it takes to update their cloud infrastructure, going from 18 months to just 16 days. And it gave them the ability to shift from what was a multi-month process to deploy a cloud to just a single day. They're extraordinary results, but possible for all of our CSP customers. Now, why has automation become so critical, and what's so special about Telco Cloud use cases that makes them so challenging? To answer this question, let's take a minute to review a couple of definitions and look at the evolving Telco Cloud architecture. As I presented earlier, Telco Cloud refers to clouds that host telco infrastructure services like 4G and IMS. The term edge clouds in this context are a highly distributed form of Telco Cloud where you might host 5G edge services or RAN workloads, bringing the compute and the applications closer to end users. As for architectures, I assume most have knowledge of the first three phases of this slide, so let's jump to where we are today, in the cloudified realm. Here, some services are delivered as virtual network functions on virtual machines orchestrated by OpenStack, and others are container network functions deployed as containers and orchestrated through Kubernetes. While this mixed VNF-CNF environment isn't ideal, it's something the industry needs to manage for the next 5 to 10 years. Luckily, CN2 supports both OpenStack and Kubernetes to simplify this hybrid SDN model. Where we're headed is to a purely cloud-native environment where applications like 5G have been developed specifically to run as microservices on Kubernetes. With microservices, the control plane and forwarding plane services that were once local to a machine, they're now connected across the network. So as standalone workloads, these 5G services are just chewing up resources on servers somewhere in the ether. But when they're connected across the network, these workloads become revenue-generating services. Now, the dependency on the network in a cloud-native microservices world is huge, hence the webinar title, The Cloud's a Network. Now, let's look a little bit deeper at the 5G architecture, or as I like to say, a face only a mother could love. Now, the first thing that likely comes to mind is that 5G isn't simple. In fact, I'd argue that the 5G architects likely made things more complex, but their goal was to design an open architecture that was scalable, performant, and multi-vendor to move CSPs out from under the thumb of single-source vendors. Now, 5G builds on the disaggregated 4G architecture with a set of cloud-native microservices that together make up the 5G services-based architecture. These services communicate across APIs and well-defined signaling interfaces across a message bus. Now, as we just talked about, these microservices are geographically independent, so while the diagram appears to show them sitting next to one another, the reality is that they're probably sitting in separate subnets physically apart. Now, from a network point of view, there are two primary areas I want to point out with 5G. First, the cluster architecture of the 5G core services, and second is the complexity with assuring the quality of the 5G services delivered to your customers. Now, let's start with the 5G cluster architecture. In a cloud-native environment, clusters are domains of Kubernetes orchestrated compute. The microservices and apps are deployed as pods with connectivity and security within and between clusters provided by networking solutions like CN2. It may be possible to purchase a lab version of a 5G core service as a single cluster, but the production 5G services that I'm aware of deploy each 5G function within their own separate self-contained cluster. So what? Well, with each cluster, you need Kubernetes to orchestrate your compute and storage, and CNI to manage the networking, both of which consume their own compute and storage to operate the cluster. Now, as the network scales, so does the number of clusters. And as 5G services span from centralized data centers to highly distributed edge and O-RAN clouds, so does the complexity and the cost of managing an end-to-end network. Given the scale of a telco network can extend to thousands of locations, CSPs are vulnerable to cluster sprawl and the resulting cost and complexity that comes with it. Now, one of the ways to scale these networks and contain cluster sprawl is to deploy a CNI with full SDN capabilities to manage these clusters from a central location. For example, CN2 uses a centralized controller to provide a single CNI across clusters to simplify management at scale, reduce OpEx and CapEx costs, and enforce consistent security policies across the entire network. As new clusters are created, they plug dynamically into the network fabric to simplify operations even at scale. In fact, CN2 is now supported on Amazon's Elastic Kubernetes Service, or EKS, which allows operators to run your controllers from the public cloud or even federate multiple SDN controller domains under a single centralized SDN controller that's either on-prem or within EKS. So you have deployment options. Now let me shift to the second point, troubleshooting and service assurance. As we discussed, these 5G clusters are deployed as unique subnets with each cluster physically separated from the others across different servers, switches, and likely even sites. So for example, the access and mobility function, or the AMF, it needs to signal to the session management function, the SMF. While these clusters may be logically adjacent, physically, they may have to cross multiple hops to communicate. Now, while products like Apstra and CN2 automate the deployment and lifecycle of these complex networks, automation can't solve the need to troubleshoot, resolve performance issues, or locate and isolate problems. In a Telco Cloud, the value of active assurance is to test out a service prior to customers and locate problems much faster, which is especially critical in a distributed CSP network. Given you can't improve what you can't measure, Juniper offers a suite of automation products and tools, including Paragon Active Assurance, which uses synthetic traffic generation and networking agents to trace performance, loss, bandwidth, latency, and the overall quality of services being delivered to customers. These tests can be automated for continuous monitoring and assurance, or on demand to investigate potential problems. The agent software runs as a VNF or CNF to look inside the physical network, hop by hop, as well as inside and across the cloud. And one new enhancement is the introduction of a mobile client, which allows you to perform service assurance across the RAN to verify 5G service quality before a live customer is ever brought online. So again, there's a fantastic group of demo videos available on the Paragon site at juniper.net, so I encourage you to take a look if you'd like more information. And finally, let's talk about cloud security. Security itself isn't a product, it's a strategy that goes well beyond my own limited areas of expertise. But what makes telco security so demanding is, yes, you guessed it, it's scale. It's really easy to do something once, but it's really hard to do anything at the scale that telcos have to deal with. So think of it this way. Hyperscalers combined may have hundreds of physical data centers globally, while service providers have hundreds of thousands. So it's a massive attack surface that requires a multi-layered security strategy to protect these assets. Now, Juniper identifies 4 primary areas of focus: the data center firewall to literally protect your centers of data, intra-data center security to protect and isolate workloads and virtual networks, data center and cloud connect services to securely interconnect RAN, edge, telco, and data center sites, and public cloud interconnects to extend your security policies to the public networks. Now, Juniper approaches security with a set of physical, virtual, containerized, and cloud-hosted security solutions that together secure the physical to the physical to the virtualized, and the virtualized to the cloudified. Within the Telco Cloud, there are several key use cases where security plays the leading role. Now, one clear example is within Kubernetes networking. As I hinted earlier, the problem with Kubernetes networking is that it's flat, meaning there's only one subnet for all workload pods, so everyone is in each other's business. Now, if you want further isolation, let's say to keep your development and your system test users and workloads isolated from one another, you need a CNI like CN2 to provide high-performance routing and microsegmentation in the server. Now, there's several different isolation models to employ, including network policies, custom pod networks that would use VNRs, or isolated namespaces. I recommend a great demo posted by Rasika Subramanian from our PLM team, which uses a familiar e-commerce shopping example to demonstrate how namespace isolation simplifies microsegmentation. Another key area is the creation and enforcement of service chaining that's both dynamic and policy driven. In this RAN example, CN2 is steering centralized unit or CU control plane traffic through SRX encryption to a distributed RAN cloud. Within the RAN, a remote distributed unit or DU is co-hosted on a single server with Juniper's cloud-native router, which provides high-performance, low-profile, software-based routing for Kubernetes clusters and is ideal to cost-optimize high-volume cloud networks like RANs. And finally, we've all seen news reports when cloud providers or network operators are hit with a DDoS attack. We don't like it when applications become unresponsive. And if you're a gamer like my kids, you're passionate about keeping our data centers and networks free of extraneous traffic. Well, whether you know it or not. So for this use case, Juniper has partnered with Carrero to integrate specific DDoS telemetry capture into our MX and PTX routers, which act as data center gateways and interconnects so that DDoS attacks can be identified and programmatically shut down at their source before they ever lag your Call of Duty gaming experience. I want to thank you for attending this webinar. I know I covered a lot of information, but I hope you found the material helpful. If you'd like to learn more about any of these technologies, I encourage you to visit juniper.net. From our landing page, you can navigate to events and demos to find helpful videos and even download free trial versions of our products to try them out in your own lab. Also, if you're further along in your cloud journey, but you can't do it alone, our partnership with the IBM Cloud team and their integration labs in Dallas are here to help you to design, deploy, integrate, and manage your cloud environments. Just reach out to your local Juniper account team. Thank you.